Good afternoon, everybody. It's so great to be back with you. Nikita, Harshita, Parth. Yes, a very good afternoon to all of you. Yes. Today we are going to deal with the topic of probability. Oh, so many of you. Devjyoti, Ananta, Jannavi, Apurva, Ankur, Chanchal, Vaidehi, Bhumika, Asha. Yes, Vaidehi. Akshata, Shreya, Ruhani, Khushi, Pritu, Amar, Sakshi, Vidisha, Deepika. Okay, a very good afternoon. Let's just shift this up. Yes. And so, now in the chapter of probability, what is happening is that we are using concepts of sets also. So, if you find something, you can revise your sets, and then it becomes easier for you to follow. So, this was the earlier distribution of sets of the whole statistics portion, and probability is an important chapter on it. Now let us talk about what do you mean by random experiment, or what do you mean by chance. Now the theory of testing hypothesis and the theory of estimation are based on probability. Okay, so what is subjective probability and what is objective probability? When I'm talking about the subjective probability, it is what a person learns from his personal experience, attitude, biases, and beliefs, okay, in the way he's been brought up. And objective probability is which is based on experiment, okay. So it is based on experiment. It is a performance that produces certain result. It's not based on what I think or what my attitude is towards a certain thing. No, we are talking about objective probability, and which we are going to study. We are not studying the subjective probability. It may be simple or it may be composite. Simple or elementary means it cannot be decomposed into another events. Okay, so that is a simple single event that occurs, and so we say it is a simple objective probability. In case of composite, what happens is the event can be broken down into smaller events, and that is known as composite. Okay, a very important mutually exclusive or incompatible, not or, this is one, you can say incompatible events, then exhaustive events, then equally likely events. Okay, so all these are very important words when we are dealing with the concept of probability. Okay, Sriniti, yes, very energetic afternoon. Yes, Dhruv, Prasad, Anjali, Shazia, Mohit, Pratima, Mohammad, Vansh, Harshini, Palak, Tanvi, Navya, Ayush, Dhruv, Nazia, Ankit, and Pavan. Okay, yeah. So now we are talking about the mutually exclusive events or incompatible events. Means that once one event occurs, the other event automatically will not occur. Okay, so this, for example, when I am tossing a coin, what happens is either I will get a head or a tail. So the moment I have a head, what does it mean? That there I cannot get a tail. Okay, so I'm talking about an example of flipping of the coin. सिक्का उछाला है आपने, तो that is known as flipping of a coin. So you can get a head or a tail. Okay, so if I get a head, it automatically means I will not get a tail. Okay, so that is mutually exclusive. Okay, and the events are incompatible. That is, I cannot have at the same time both heads and tails. Okay, exhaustive events means what? I have considered all possible things that can happen. Exhaustive events means I have considered all possible events that can occur. Okay. Equally likely events is that all events are equally likely. That is unbiased. Like if you remember Shakuni Mama from Mahabharata, so what he used to do is his dice was biased in the sense that the center of gravity of that dice was shifted, and therefore the depending on how he threw the dice, he used to be able to predict what number it is going to come. But we are not going to consider all that. We don't want a Mahabharata in my paper. So what I do is I simply talk of equally likely events. So if I'm throwing a dice, so what happens is the probability of getting a 1, 2, 3 are all equally likely. Okay, there is no one number that is favorite for anybody. Okay, so that is called as equally likely. Exhaustive means I've considered all. So like when I'm tossing a coin, say dice, what is the exhaustive events? Getting numbers 1, 2, 3, 4, 5, 6. Okay, so exhaustive events in case of dice will be what? Getting 1, 2, 3, 4, 5, 6. Can I get a 7 on a dice? No. Okay, I know I can't get a 0, I can't get a 7 and above. Okay, I can get only 1 to 6. So those are the exhaustive events that can, that are the all possible events that can occur. Equally likely, I've told you, mutually symmetric events are similar, they say. Each event is equally likely to occur. What these words are, these are different words implying the same things. So I have written all the words so that whenever like you're reading through and then you find this new word, you should not get confused. You can always come back to this PDF and see, oh yes, if I'm saying incompatible, it simply means it is mutually exclusive event. Okay, clear till now? Just put it in the chat box. Yes, Rohit, good to see me back. Even I'm happy to be with all of you. Dhanesha? Yes. Venkat Lakshmi? No issues. I just started. Okay. Amit? Yeah. So we are just talking about the very, very basic words and terminology that we are going to use in the chapter on probability. Now, this is the classical definition of probability, which you may get for a theory question. Yes, very clear. Yes, Neha, Rohit, Amar, understood? Absolutely clear, Rohani? Yes, absolutely nice. Nishi? Now, what does the classical definition say is that if there are n finite simple events, okay, so the finite word is very important, which are equally likely, then the probability of event A occurring is given by PA is equal to N of A upon N, where N is the total number of possible events and number of events favorable to A. What does it mean is, for example, I'm talking about the dice. So what is the possibility? 1, 2, 3, 4, 5 and 6. So what is N? N is 6, right? What is the probability of getting a 2? How many 2s are there on the dice? Only 1. Okay, so N of getting a 2 is 1. I can have only 1 2. So P of 2 will be equal to N of 2 upon N, which is equal to 1 upon 6. So getting a 2 on the top of the dice, what is the probability? 1 upon 6. Okay. So total number of events favorable to A, whatever the event A here is. Okay. In this case, we said getting a 2 on the dice was an event. Okay. And total number of possible events. Okay. Now the priori definition, which is given by Bernoulli and Laplace, says that number of mutually exclusive, exhaustive, and equally likely events favorable to A. This is mutually exclusive, exhaustive, equally likely events favorable to A upon total number of mutually exclusive, exhaustive, equally likely event. Okay, let's write it as total. Okay, so that is this is a broader definition where we are considering all the possibilities that can occur. Okay, then there are very important formula that you use not only now in probability, but you also use in the probability distribution. Okay, so what are those? We are talking about expected value, you are talking about mu, you are talking about variance, you are talking about standard deviations. Okay, so why that is important is that I may see, okay, probability, but that does not give me the entire picture. I have also to talk about the volatility of this. Especially this is all used, in what where we are tracking stock market prices. Okay, so when I'm saying this, that what is the probability of earning 10% like rise in price of a particular share. So when I'm talking of that, I have also to consider that what is the range within which this price is moving. Okay, that is called as the standard deviation. You've already done that. Okay, yes, with sir. So now the concepts are all there with you. So we are talking about that. Okay, so we're talking about, see, suppose I'm trying to buy a share of Reliance or Infosys or TCS, so what is the volatility, okay, vis-a-vis the volatility of a small or a medium share. Okay, so those adjustments also we have to consider. So that is why we have to learn this concept, because when that happens, when we are talking about risk management, all these things are going to play a very important role over there. And so knowing these concepts are going to be a very good advantage for you, especially like students who are coming in from foundation and who have really not put all these important chapters into, like, option, I will not do this, this is difficult, etc., etc. Those students do very well in the finals also. Okay, so this is very important. So we are talking about expected value, okay, which is represented by mu, which talks of summation of x into p. What is x? X is that value we are talking about, and p is its probability, like getting on a number on the dice, or how many heads or tails. Okay, so getting a if I'm flipping a coin, suppose I'm flipping two coins, so getting a head on the first coin, getting a head on the second coin, all those things we are going to talk about, and the probability of that occurring. Then we have e of x. Oh, sorry, it's not, it is e. So what do you have? E of x square. What is it given by? Summation of x square star p. Okay, remember this square is for the x and not for the p. Okay, and then we say variance. Okay, if we have learned about variance, which is sigma square is equal to e of x square minus mu square. Okay, e of x square minus mu square. And what is sigma? That is the standard deviation. Okay, which is also volatility in finance. It is the square root of variance. Okay, so these are important formulae that you should know. Okay, so make sure you are writing them down, and then we are going to like have the probability distribution table, and from there we could do that. Okay, so suppose I make a probability distribution table. So I have 0, 1, 2, 3. Okay, these are the events, like x can take the value 0, 1, 2, 3. So this is x, and this is some probability. Okay, and then I will have xp. I will multiply x into p, and then I can have another x square, and then I can have x square into p. So this is the kind of table I will make. Okay, this is, is a probability distribution, and then for calculation ease purpose I will write it like this, and then it becomes easy for me to like calculate also, and don't make mistakes. Okay, now let us talk about the properties that we should keep in mind while we are trying to understand what is probability. So these you can get for theory also, and also application of them when we are doing the problems. Arshita, okay. Mutually exclusive means what? When one event occurs, the other will not occur. Okay, when I am flipping a coin, I will get either head or tail. Can I get both when I flip a coin? Try doing that. No? You can get either the head or the tail. That is called as mutually exclusive event. One event is will occur, then the other will not occur. Okay. Uvarasi, equally likely events means every event within that universal space that we are talking about will have equal chance of occurring. Okay. Gauda, yes, good afternoon. Yes, Vardhan. Vardhan, you have to write the doubt also, okay? Have you written it earlier? Okay, just write down your doubt. Yes. Yes, I was missing you. I was missing all your emojis and lovely things that you send me. Yes. Yes, Dhanesha, what happened? Just let me know. Yes, Khushi, I can write the variance formula once again. Yeah, no problem. Vardhan, you can post your doubt. Okay, you know that standard deviation is what? It is square root of variance. Okay. Yeah. You've learned that already? Measures of central tendency, you've done that. So now we are talking about, yes, Dhanesha. Yeah. Okay. Probability value. Whenever you calculate probability value, its value is going to lie between 0 and 1. This is very, very important so that when you make the calculation, if you're getting 1.5 as probability, which even now I make a mistake, and then when I see that, oh my God, I have made a blunder somewhere, because your probability cannot exceed 1. You cannot be more than 100% of something, you can be sure of that. We may say it, like in friends or something, like you say 200% sure, but that actually is not possible. So what we say is 100% is the maximum. So we are saying that probability is going to be 0. Either it can be 0 or it can be maximum, it can take the value 1. So can you appreciate? You cannot have a negative probability. Okay, 0 to 1. Okay, second, if A is an impossible event, then P of A is equal to 0. Okay, me traveling to Neptune or Pluto is an impossible event. So I will write that is P of A as 0, that the event cannot happen. If A is a sure event, okay, so 100% only that event is going to happen, then we say P of A is 1. Okay. Non-occurrence of event A is denoted by A dash. Remember, now that's what I'm saying. Remember what we did in sets. Set like A is that event will occur and A dash will be event will not occur. Okay. Always remember, if the event occurring plus the event not occurring, the probabilities will always add up to 1. Okay, so this is very important. Helps you in solving problems also. P of A plus P of A dash is always equal to 1. And in the formula style also, P of A is Na upon N, then P of A dash is N minus Na upon N. So P of A dash is equal to N minus N of A upon N. Okay. Then this also, I have purposely written it here only because we also have a lecture tomorrow, day after, but I want you to have all these things together at one place, is that odds in favor and odds against. Okay, so you have sums on that also. So odds in favor of A is the, not ration, it is ratio, is the ratio of number of favorable events to the number of unfavorable events. Okay, normally when we are calculating probability, what we do is N of A upon N. What is this N? The total, right? But here what we are talking of, odds in favor, we are saying is, so you will get a ratio. Okay, it will look like this. So for example, okay, 3:5. This is just an example. So what does this mean? This 3 represents what? It is in favor and this is against. Okay. So suppose I do the experiment 3 plus 5 8 times. The event will be favorable 3 times and not favorable 5 times. Okay. Odds against is what? Just this n minus na is to a. Okay. So these are similar, but this is in favor and this is not in favor, and which is called as against. Purposely I'm taking a little slow because so I want all of you to be very, very clear about your concepts. Yes, Rohit. In the movie Sholay, Viru has the coin which is heads on both sides, so it's a biased coin. It's not an unbiased coin. Nishi, n of a is what? Number of times the event A has occurred. Okay. As if you will have to mail. Yes, Bhavani. Good afternoon. Yeah. Okay. Now we have. Let us talk about the coin in detail. Okay. See what happens. I have one coin. When I have a single coin, I have the single coin. Okay. So either I can get a heads or a tails. So what is n? N is 2, 1 and 2. What are the possibilities? 2. Now, what is, how many heads, how many times do I get a head? One time. How many times do I get a tail? One time. So out of the two events, one time I can get a head, one time I can get a tail. So probability of getting a head is n of a upon n. So what is n here? A here? It is n of h. Number of times I can get a head upon n. What is n? The total number of events that can occur. Event can be either a head or a tail. So this is denominator is 2. Head, how much I can get one time? So I am getting 1 by 2 or 0.50. Similarly, P of tail will be equal to n of tail upon n. How many times can I get a tail? When I flip the coin once, I can get it only one time. So 1 upon 2, which is equal to 0.5. Is that clear? And this was very simple. Now let us go to two coins. What happens if I simultaneously flip two coins? So what can happen is first we are going to talk about the first coin and then we will talk about the second coin. Okay. So when I flip the first coin, I can get a head or a tail. What is the probability of getting a head? Probability of getting a head is half. Probability of getting a tail is half. Okay. So getting a head is 0.5. Getting a tail also is 0.5. 0.5 plus 0.5 is 1. Always appreciate that the addition is coming to 1. Now once I've seen this, I look at the second coin. So after this head, I can either get a head for the second coin or I can get a tail on the second coin. Okay. When I get a head on this, so now this is a second coin. So what is the probability of getting a head here is half. Again half. Okay. Now if I get a tail with the first coin, again I flip the second coin. Okay. I can see what has happened to the second coin. Again I can get a head or I can get a tail. Okay. Head or a tail. So when I flip both the coins, what will happen is I can get a head and a head. How many times? One head I can, probability is 1/2. Two heads. So this 0.5 will be multiplied by, this 0.5 will be multiplied by this 0.5. So it is 0.5 into 0.5, it is 1 by, which is, so getting two heads is equal to 0.5 into 0.5, which is equal to 0.25. And in terms of fraction, it is 1/4. Getting a one head is how much? Is 0.5. Okay. Now getting two heads is this. What happens with one tail? One tail is 0.5 and two tails are, two tails is this 0.5 into this 0.5. So 0.5 into 0.5 is equal to 0.25, which is equal to 1/4. Now this one head was 0.5 here. Now this one head, I can get, see what happens when I'm doing this. Let me just write it over here. Just let me write what can happen. When I flip two coins, what will happen? Either I get a head, or I get a tail, or I get a head tail, or I get a tail head. Okay. These are the four possibilities. What, this is how much? This is one, first head and second head, 0.5 into 0.5. That will give me 0.25. Now tail also I got this. So this I have done, this I have done. Now head, tail and tail head. What is the possibility when I get one head? It is this, and one tail it is this. Okay, single. Okay, so here and here I am talking about. Now what will be the probability here? I'm getting one head and one tail will be equal to 0.5 into 0.5. Okay, and one tail and one head will be again 0.5 into 0.5. Okay, so this is the way you have to, like, when you're doing the sums, you could use it. So what is this? This is equal to 0.25. This is equal to 0.25. So when I'm saying only one head, what will that be? 0.5 plus 0.5, which will be 0.50. 0.25 plus 0.25 will be 0.50. Okay. So you can appreciate this. So here I have shown you what happens when we are flipping three coins. You can refer to this slide. This is a very important slide. This will give you the understanding of the, it's a summary of the whole chapter of this probability. Okay. So when I flip three coins, okay, when I flip three coins, what is the possibility? I get one head, I can get a zero head, I can get one head, two head, or three head. Okay, these are the possibilities. So when do I have a zero head? Zero head will be there when there is T, T, T. Okay, this is the zero head. One head scenario, H, T, 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 H, T, and T, T, H. Okay, these are the scenarios when I have one head. Two heads will be HHT, HTH, and what else? THH. Okay, right? And three heads will be 1, 2, and 3. Three heads. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what are the, this is what? This is the total events that are likely to occur. So you cannot have an event apart from this. Okay. All events have been considered. For this is what? Zero heads. This is one head, this is two heads, and this is three heads. Okay. And so now let me see. So I write down 0, 1, 2, 3. Now probability of getting a 0 head. How much is this? How many total are there? The total 8. Okay. Now how many times do I get a 0 head? 0 head, it will be 1 by 8 because this is only 1. How much is this? 1, 2, 3. This is 3. This is 3 and again 1. 3 plus 3, 6, 7 and 8. How many times will I get one head? See, 1, 2, 3. So I will write down as 3 by 8. 2 heads is again 3 by 8. 3 heads, only one time it occurs that when I'm flipping 3 coins, all 3 have head. So that is 1 by 8. Now if you add them up, 1 by 8, 3 by 8, 3 by 8 and 1 by 8, the total comes to 1, which is very necessary because probability is always going to be equal to 1. Addition of probabilities. Okay. And then I can even write, I've done this in decimals because if sometimes, in the exam, they will not put a fraction, they'll put a decimal, or you have a decimal on the calculator. Now you need to convert it into fraction and tick the correct answer. And that's why this is going to be important. Okay. And then I find the expected value. What is the expected value over here? Okay. So 0, 1, 2, 3. Okay, this is the value of x. The value of p, I got it as 1 by 8, 3 by 8, 3 by 8 and 1 by 8. Again, if I add them up, it is 8 by 8. So probability is 1. Then what I do is I find out xp. 0 into this is 0. 1 into 3 by 8 is 3 by 8. 2 into 3 by 8 is 3 by 4. And again 3 by 8. Okay. So 3 plus 3 is 6. X into P. Okay. Yes. And then I have x square. What is x square? 0, 1, 4, 9. Okay. I have x square. And then I will have x square into P. So x square into P will be what? 0 into P is 0. Then 3 by 8 into 1 is 3 by 8. Then I have 3 by 8 into 4 is 3 by 2. And 1 by 8 into 9 will be 9 by 8. Okay. So this is the way you will calculate. And then you can find the expected value. Expected value for this will be, this is my expected value. So 3 by 8 plus 3 by 4 plus 3 by 8 gives me 1.5. Then e raised to x square. E raised to x square will be this. Will be equal to this. So 0. This is 4. 4 3s are 12. 12 and 12. 24 upon 8. Which is equal to 3. Okay. And then I will have variance. Variance is what? Variance is e of x square minus mu square. So what is e of x square? E of x square is 3 minus mu square is 1.5 square. How much is 1.5 square? 2.25. So this is 3 minus 2.25. Answer is 0.75. So what is the variance? Variance is equal to 0.75. Oh, okay, I hope everybody is understood. Yes. Dhanesha, today and 24th will be the days that are dedicated to probability. No problem, Saloni, no problem. Yes, Ankit, it is enough, If you do the exercises thoroughly, in the study module. Now you even have the new study material available. So you could even refer to that. So that is the case. So now we have talked about dice. Now let us talked about coin. Let us talk about dice. I hope everybody has understood the coin. Let me just check. Yes, Nikita, crystal clear. Shama, what happened, Shama? You just have to flip a coin, okay, which is very practical. You take 3 coins, you flip them, you see how many times you get a head, how many times you get a tail, and you write it down. Okay. Now, when 2 dice are tossed, what are the possibilities? Is what is the probability of 1 dice? What are the possible for 1 dice? Is equal to 6 possibilities. What are those? 1, 2, 3, 4, 5, and 6. When it is 2 dice, again you will have all the combination, like you will have 1 1, okay, 1 2, and so on. Okay. And then what you when you're tossing 2 or more coins, two or more dices, you can add, add or subtract the numbers that are appearing on the top of the dice. Okay, so those are also the type of questions that can be asked. So here we are talking about, see, total 2 3 4 5. So what is happening is, what is the total on the top? For 2 it is 1 1. Okay, so 1 on the first also I need to have a 1, on the second dice also I should have a 1. So P total of 2 is equal to 1 by 36, which in decimal is written like this. What is the total when I get 3? I can get 1 2 or 2 1. Okay, so what happens is, these lines are also very important, because it is not always about the order. Okay, it is also about whether or not I get a number, or whether or not I get something, related. So every time you not have to think only of one scenario, but you have to think of the other scenarios also. So what happens when I'm tossing 2 coins? I will add the one on the top. Okay. So if I get a 1 on one dice, and if I get 1 on the other dice, what will be the total? 1 plus 1, 2. Okay. How many times can I have that? That can occur only once. Okay. So 1. For 3, what can be? I can have 1, 2. On the first dice, I have a 1. On the second dice, I have a 2. Or it can be the opposite. On the first dice, I get a 2. And on the other dice, I get a 1. Okay, so that is also possible. And so on. So can you just see this and appreciate? Okay, so these are the possible things. So I can, when I have dice, I will have this concept about adding them up. Okay, adding on the top. So numbers like I can, the numbers will range from 2. The addition can be from 2 up to 12. Why 12? because it may be possible on the top of the dice you have 6 on both the dice, which is very rare, but it may happen. So 6 on both the dice is 6 plus 6, 12. So you can have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What I have done here is on this slide I have taken 2 to 6 and on the other slide I have taken 7 to 12. So 2, how many times, how many will there be? 1. So what is the possibility of the addition being 2 on the dice? It will be 1 upon 36. Okay. Then here what will happen? It will be, see here I have written probability will be 1 upon 36. Then probability of getting addition equal to 3, it is, there are two possibilities, so 2 upon 36. Okay. And these are all the decimal numbers I've calculated. So just like when you're revising now, those numbers will stay in your head. So for addition to be equal to 4, what can I have? On the first dice I can have a 1 and on the second I can have a 3, or I can have 2 and 2, or I can have 3 and 1. Okay, so these are the possibilities, and then I get 3 upon 36. Then for 5, I have these 1, 2, 3, 4. So 4 upon 36. So getting a 6 on the addition as 6 on, when I add the numbers on the dice, it will be 1 by 5, 2 by 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. Okay. Now the remaining 7 to 12. So addition of 7, when how many times can I get it? It will be 1, 2, 3, 4, 5, 6. So 6 upon 36, 8, 5 upon 36, 4 upon 36, 3 upon 36, 2 upon 36, and 1 by 36. So if I add all this, I should get as 1. Okay. Now let me explain what the cards are. We have, talked about what? We have talked about coin. We have talked about dice. Okay. And now we are going to talk about cards. Playing cards. ताश के पत्ते, उनके बारे में बात करेंगे. Okay. Good. Everybody is understanding. That is very important that all of you understand. Now what we are going to do is we are going to talk about cards. So, like all of you would like to play cards. So, that you. Now what is happening is a deck of cards contains how many? 52 cards. Okay. You have 52 cards, and in the 52 cards, what do you have? You have the club. Okay, I'll just show you. You have the diamond. You have the spade. And you have the heart. Okay. इसको किलबिल बोलते हैं, किलवर. इसको डायमंड को डायमंड इज नोन एज पान, स्पिक, इसको क्या बोलते हैं? Can anybody just put me in the Hindi word for diamonds? Silver, spick, pan, or no, you don't. You need not play. You just need to know how to answer the questions. Okay. Eat. निशी eat बोलते हैं. Okay. So That is what you must remember. Okay, so what if I'm talking about 52 playing cards, remember half of them are red and half of them are black. Everybody knows that much. Okay, so which are the black ones? The black ones are the club and the spades. Okay, so those are the black colored one. काले जो पत्ते होते हैं वो कौन से होते हैं? वो इस्पिक के और किल्वर के पत्ते होते हैं. And which are the red ones? Red ones are heart, and the diamond ones, those are pan or eat ke patte. Okay, so you know that out of 52, 26 are black, 26 are red in color. So, then there are 4 aces. Ikka. Ikka jo hota hai, those are known as aces. So how many aces do I have in there? So I have 4 aces. So what will be the probability of getting a ace? It will be 4 by 52. Okay, so if I'm talking about what is the probability of getting an ace? How many aces are there? 4. How many total number of cards are there? There are 52. Okay, so this is 2 upon 26, which is equal to 1 upon 30. Okay, right? So what happens is, then that is about the ace. Then you have 3 picture cards. Okay, Gulam, Begum or Badshah. Those are known as picture cards. Okay, so king, jack, queen and king. Those are known as picture cards. So how many total number of jacks will there be? 1 for each color. Okay, 1 for each type. So you will have a jack of hearts, you will have a jack of diamonds, you will have a jack of club, and you will have a jack of spade. So what do I have? I have 4 jacks. So what is the probability of getting a jack? It will again be 1 by 30. Okay. Similarly, 4 queens, again the same thing, and 4 kings, again the same thing. Okay. You have 4 kings and 4 queens in the entire deck of cards. Okay. It is called as deck of cards. The word is deck. So how many total picture cards are there? 4 jack, 4 queens and 4 kings. There are 12 picture cards. Okay. So what is the probability of getting a picture card? Will be equal to 12 upon 52. Okay. Will be equal to, this is 3 upon 30. So there are total number of cards. So the total cards for each color will be ace, 1, 2, up to where? Up to 10 numbers, serial number. Then I'll have a jack, I'll have a queen, and I will have a queen. 1, 2, this will be 11, 12, not 1. Ace, 2 to 10. Okay, you will not have 1 again. 1 is represented by ace. Okay, so 1, 2 to 10, that is 9 plus 1, 10, 11, 12, 13. So there are 13 cards. Okay, for each type. So as I've already showed you, probability of getting a ace is same as probability of getting a king, is same as getting a queen, jack, which is equal to 4 by 52. Getting a spade, heart, diamond, again it will be 13 by 52, which is 1 by 4. Then getting a king of spade, how many kings of spade will be there? So you will have only 1 king of spade. So it will be 1 by 52. How many queen of hearts? 1. So 1 upon 52. So this is also 1. How many probability of getting black? How many black cards are there? 26. How many total cards are there? 52, which is equal to 1 half, which is equal to 0.5. And same thing. How many red cards are there? 26. Upon total cards is 52, which is equal to half, which is equal to 0.25. Have you understood the cards? Any difficulty, please let me know. Uvarasi, what have you asked for? 5 means no number of dices, ma'am. I did not get your question, you know. Could you do? She is saying eat. Rohit is saying eat. Okay. No, Vidisha, it's called Hira in just a normal Hindi, but the deck of card has what they said, eat. Rohit, from 1 to 13, number of cards are 4. How can you have 1 to 13 number of cards as 4? Okay, Rohit, what is happening is how many picture cards are there? 4. Okay, 4 for each type. Okay, 4, 3 for each type, and then you also have the ace. Okay, picture cards are 3. Yes, Nikita understood very well. Okay, Bidisha, king of spade. What is happening? How many kings of spade do you have? You have 13 cards of spade. In that, how many kings do you have? You have only one king. Okay, so that is why it is 1 by 13. 1 by 52 because total number of cards is 52. So spade, there is a single spade card which is a king card. So 1 upon 52. Any other doubt you have? Let me just check. Understood? Red card probability is also half. Oh, sorry, yes. Not 0.25. Fine, very good. Who is this telling? Yeah, yeah. Thank you so much. This is not 0.25, this is 0.5. 1 by 2 is 0.5. Is you called as kilver or chidi and eat. Yes. Is Vidisha, have you understood? Nishi, spade is called as ispik or also called hukum. Somebody has written hukum also. But I think hukum, like you, that is not the name of the card. Hukum is like we say that hukum will be pan or hukum will be this thing. Okay. As far as I know, it is known as speak ke patte, but still somebody's written hukum also. So it depends on which area of North India you belong to. No, no, Palak, this is by mistake. One half is 0.5. Okay. Sorry for this. Okay, Asha, what happens is in a deck of cards for suppose I'm talking of the cards of spade. So you don't have a card written as one. Okay, all the other cards are numbered. You will have two spades on the card, three spades on the card. So 2, 3, 4, 5 numbers are written. For the single one, it is written as A on the top. Okay, for the single one, it is written as A on the top. That is why it is called as a ace of spade. Okay, and then you have 2, 3, 4, 5, 6, 7, 8, 9, 10. The 11th card is the jack. The 12th card is the queen, and the 13th card is the king. Clear? Yes. Yes, Nazia. 13 hearts, 13 spades, 13 diamonds, 13 clubs. Correct? 52 cards. 4 aces, 4 jacks, 4 queens, 4 kings. Total 12. No, 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 no. These jacks, queens, kings are part of the 13. Okay? It is not 13. No, you don't have in cards numbers 1 to 13. You have from 2 to 10. First is the ace, then you have 2 to 10, and then you have this jack. I hope I have some place where I can write and show. Okay, I'll just show it to you here. Suppose I'm talking of spade. What will you have? This will be the first card. There will be one spade drawn. Okay, and then A written over here. Then you will have second card. So this will have 2 written like this. You will have a 10 written, okay, and then you will have a card with a jack, then you will have queen, and then you will have the king, okay. So this is card number 1, card number 2 up to, then this is card number 10, this is card number 11, 12 and 13, okay. So how many cards are there? 13, okay. So for a deck of cards which are for 52, what is the distribution? You have 4 aces, 4 jacks, 4 queens, 4 kings, 1, 2, 3, 4. How many are there? 12, 16. So out of them, remaining will be the number cards. Okay. So how many are there? 52 minus 16. 6. 36. Yes. 9 fours are 36. Okay. So 36 cards are non-picture cards or number cards. Okay. I hope now everybody has understood this. Yes. Very good. ध्रुव मैं अच्छी हूँ. What is the probability of the face card? Amit, how many face cards are there or picture cards are there? 12. Okay. Jack, queen and king for the 4 types. So 4 into 3. So that is 12. So 12 upon 52. So picture cards, probability of picture card, 12 upon 52. Then you can simplify 4 3s and 4, 1 and 3. So 3 upon 13. Yes, Amit, you've understood now? No, Vidisha, cards are not confusing. It will become very simple. When you try to solve, oh, I feel it is the other way around. Solving card problems are easier. Chaitanya, we don't talk about the Joker here, right? Joker is an extra card, right? It does not belong to the 52 cards. Yes, 36. Yes, Saloni, Venkat Lakshmi, thank you. Okay, which cards are red? See, spade and club are black in color, and then heart and diamonds are red in color. Okay. Yes, Nishi, break is there, right? Wait. Yeah. Okay. So I just hope you've understood this concepts are now clear, so that no, I don't want to like every time we are trying to solve a sum and then we go back to the concept. We don't want that. I'll just quickly recap and then we can go in for a short break. Okay. So we are saying that 2 types of probability. One is the subjective and one is the objective. Subjective is based on what? From personal experience, from my biases, from my attitudes, etc. And then we are talking of the objective type of probability, which is based on the experiment. So the experiment may be simple or composite. In simple, you cannot break it down. In composite, you can break it down to simpler events. Okay. Then mutually exclusive events are events that when one occurs, automatically other will not occur. Mutually exclusive, or they are also called as incompatible events. Then you have the exhaustive events. Exhaustive means that with that experiment, what are the different possibilities? When I've covered all of them, we say it's an exhaustive thing. And usually the in probability that number is given in the denominator. Then equally likely events is that when all other things are same, every possibility has equal chance of occurring. Then classical definition, we are saying when then if there are n finite simple events which are equally likely, the probability is given by n of a upon n. Then we have the formula for expected value, that is mu, which is equal to summation x into p, where p is the probability. So then we have e of x square, which is equal to summation x square into p. Then what do I have? I have variance. Variance is equal to E of x square minus mu square. Okay, so you find out the mu and you square it. But E of x square, you only square the x. Okay, and then you multiply and add. And then variance is E of x square minus mu square, and then standard deviation is equal to under root of variance. Then these are the important things that you should keep in mind for probability, that the value of probability will always lie between 0 and 1. You cannot get a negative probability. Second is that if A is impossible, its probability is 0. If event A is a sure event, the probability is 1. Okay. Non-occurrence of event A is denoted by A dash, which is given by 1 minus probability of A. Then P of A plus P of A dash, that is the probability of the event occurring plus the probability of the event not occurring. When I add those two probabilities, the answer should be equal to 1. Okay, odds in favor and odds against A. Odds in favor of A is written by Na is to n minus Na, and odds against A is written by n minus Na is to n. Always remember, the odds in favor or against is a ratio. It's not one number. You have those two dots in between, like this, these dots. Okay, so these dots are there. So it's a ratio. Then for a coin, when I say toss a single coin, the probability of getting a head is half and the probability of getting a tail is also half. When I'm trying to toss two coins, the probability of getting two heads is 1 by 4. Probability of getting two tails is 1 by 4. And the probability of getting one head or one tail is given by 0.5. Okay. And then we did it for 3 coins also. And for 3 coins, there are 8 possibilities and we are able to calculate. Okay. Then we have talked about 2 dices also. So you can have, what is the addition of the two numbers on the dice, or what is the difference also. You can have those type of things. Then we talked about cards. Cards we are talking about is saying that there are 52 cards. Out of them, 26 are black and 26 are red. Then the black ones are spades and clubs. There will be 13 cards of spades and 13 cards of club. 13 cards of heart and 13 cards of diamond for the red ones. For each set of cards, maybe it's a spade, maybe it's a club or a heart or a diamond, there will be 13 cards. Out of the 13 card, one will be the card of ace, and you will have 3 picture cards, jack, queen and king, and the remaining 2 to 10, those numbered cards will be 9. So 9 plus 1, 10, 11, 12, 13. Okay. So this is how you should know. Okay. Yeah. I think let's take a break. Both heavy duty. Yes, understood. Very nice. Very. Yes, Ruhani, it's clear. Yes, Bhumika. Once you become a CA, then you and me can play cards. Yeah. Now, Uzer, you always have a jag. Having a like joker is an option for the cards. No, ace is not a face card. Chanchal, you like my teaching? Okay. Yes, Nadia, perfectly. Yes. No, no. 4 aces. 12 cards are not picture cards. Yes, total are picture cards. Yes. Okay. 4 jacks, 4 queens, and 4 kings. Very good. And 13 are non-picture cards. Excellent. Yes, great revision. Clear. Coin or diamond clear, Amit? Good. Om is saying crystal clear. So, um, Amit is saying it is coin or diamond clear. Yeah. Okay. Let's take a break for 10 minutes and come back and we'll dive into some beautiful question. Okay. See you after the break. Break, Lily? Welcome back, all of you. Let's see. Srinidhi is saying, thank you, ma'am, for making it so easy. Kirti, I told in Hindi whatever the names are, okay? Yeah. I hope that is enough. If you still have any doubt, you can always put in the question, okay? I'll answer the question for you in Hindi. Okay, a coin is tossed 3 times. So let us see what are the possibilities. Possibilities is getting 0 heads. Okay, possibilities are 0 heads, 1 head, 2 head, and 3 heads. Okay, these are the possibilities. So how does it look like? 0 heads is T, 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 all 3 tails. Then 1 head, H, T, 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 H, T, 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 H. 2 heads, H, H, T, H, T, H, T, H, H. Okay. Then all 3 heads, H, 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 3 heads. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. Now what is the probability of getting 2 heads? Okay. Now let us see. 2 heads. When do I have 2 heads? So this is for 1 head, 0 heads. 1 head is from here to here. 2 heads are from here to here. Okay. So how many 2 heads are there? 1, 2, and 3. So n of 2 heads is equal to 3. So what is the probability of getting 2 heads is n of 2 heads upon n. N of 2 heads is 3 upon n is 8. So 3 by 8, or do you have in decimal also? So you can have in decimal as 0.375. Okay. Now this is a very important word, at least. At least 3 heads means what? That I can get a two heads, or I can get 3 heads also. Okay. I can get 2 heads, or I can get 3 heads also. So second part of this is at least 2 heads means I can get 2 heads or 3 heads, because we have only 3 coins, so I can't have four heads, right? Whatever the maximum limit is, that much I can get. How many 2 heads I have? 1, 2, 3. How many 3 heads do I have? 1. So n of at least 2 heads is how much? 4. And how many total heads are there? Total are there? 8. So P of at least 2 heads is equal to 4 upon 8, which is equal to 1/2, which is equal to 0.5. Is it clear? Excellent. Om, yes, you have got it. Let us go to the next sum. Coin is tossed 3 times, like the earlier sum also. What is the probability of getting 2 or more heads? Okay. So remember, 2 or more heads in this case is equal to at least 2 heads. Okay. It is all English. Okay. At least 2 or more. This mean one and the same thing. So what will happen? At least 2 heads Okay, so I can have, what is the probability of getting 2 heads? And how much was 2 heads? How many are there 2 heads? 1, 2, 3 is 3 upon 8. What is the probability of getting 3 heads? Is equal to 1 upon 8. Okay, there is only one situation when I can get 3 heads. So at least 2 or more. So 2 or more heads. What is the probability of getting 2 or more heads is equal to probability of 2 heads plus probability of 3 heads. This is equal to 3 by 8 plus 1 by 8, which is equal to 4 by 8, which is equal to half. Okay. So whichever way they ask you, this is the way you have to solve it. Again, coin is tossed 3 times. So that earlier one that we have done, yes, very good. Where did you get the 36 from? 36 is for dice, not for coins. Okay. So a coin is tossed 3 times. What is the expected value on standard deviation? Okay, so we have already shown it there, solved example. I have given it to you in the first, second slide. But here we will actually try to solve it. A coin is tossed 3 times. So what is the expected value and standard deviation? So X is what? The event that you get a head. So you may have 0 heads, 1 head, 2 head, 3 head. And then we have a total column. What is the probability of getting a 0 head? That is one possibility. Okay, I can write it down here. So you have T, T, T. Okay, all 3 are tails. Then you have 1 head. So it can be HTT, THT or TTH. This is 1 head. 2 heads, HHT, HTH and THH. These are 2 heads, and 3 heads is H, H, H. Okay. So you have to choose, like you have this whole universal space, and from there you choose. What is the expected value? For 0 heads, how many? This is only one case. This is one case of 0 head. 3 cases of 1 head. 3 cases of 2 heads, and this is one case of 3 head. Okay. So I have written this 0, 1, 2, 3. So this is how you get the numbers. Then probability 1 by 8, 3 by 8, 3 by 8 and 1 by 8. Okay. And I try to add them up. They also addition comes to equal to 1. In decimals I have written down. Now I will multiply x into p. So which am I going to multiply? This into this. 0 into this is 0. 1 into 3.75 is 0.375. Then 2 into 0.375 will be 0.675. 0.75. 3 into 125 will be equal to 0.567 and 3. 0.375. Let us see. 0.375 plus 0.375. Let me put a calculator. So this is 0.375. 0.375 plus 0.375 plus 0.75. This is equal to 1.5. Okay. This number can be greater than 1. Okay. Because it is x into p. Now I will square the x. 0 square is 0. 1 square is 1. 2 square is 4. 3 square is 9. Okay. Then after multiply the x square with p. So 0 into 0.125 is 0. 1 into 3.75 is 0.375. 4 into 0.375 will be 12, 13, 14, 15. 0.15 And 9 into 0.125. I'll just check. 4 into 0.75 is no, 4 into 0.375 is 1.5. Okay. 1.5. Decimal placing is wrong. And then 9 into 0.125. 9 into 0.125 is how much? 1.125. 9 into 0.125 is 1.125. 4 into 375, 12 and this thing. So what will be this addition? Plus 0.37375 plus 1.5. Answer is 3. Okay. So this is 3. Okay. Now I will put it over here. Expected value mu is equal to summation x star p. Summation x star p. What is the total value? This is 1.5. Then you have e of x square. Summation x square into p, which is equal to how much? 3. Okay, this 3. And so you have variance is equal to e of x square minus mu square. E of x square is 3 minus mu square is 1.5 whole square, which is equal to 3 minus 2.25, which is equal to 0.75. And then you have sigma standard deviation, which is equal to square root of variance. How much have I got variance? As 0.75, which is equal to square root of 0.75, which is equal to 0.75 square root 0.8661. 0.8661. Okay. Yes. So this is how you should like the first second slide, and this you can like use it to do the calculation. Yes, Vidisha, it is okay. But you have to see what options they have given in the paper. If you suppose all the 4 options are in decimal, so whatever fraction answer you get, you have to convert in decimal and then put the tick mark. Yes, Venkat Lakshmi, very good. Rohit, 6.75. 1.5 is correct. Yeah. Okay. Let us go to the next sum. A dice is rolled 2 times. What is the probability of getting a difference of 2? Okay. Now, they are just saying a difference of 2. It can be a negative difference or a positive difference. So, if I have the number 1, so let's see what the S will be. If I have the number 1, what will be the difference of 2? 1 minus 2. Oh, so what will that be? So 1 and 3. Okay. What is getting a difference of 2? It is only 2. Okay. So then if I take the number 4, so on one dice the number 2 is coming. So on the number other dice the number 4 should be there. Then if I have 3, then it will be 5. 4, it will be 6. Can I go with 5? 5 difference of 2, it means 7. We don't have a 7 on the dice, so this is the case. Now, when this is the case, because they're saying a difference of 2, they're not mentioning it as positive, negative. So what this means is, then this will also be 3, 1, 1, 3, 3, 1, 4, 2, then 5, 3, and 6, 4. Okay. So, I usually write it in the vertical way so that I don't make a mistake. Otherwise, the counting also it becomes difficult. So, these are now 2 rows of 4 each. So, there are 8. So, what is the probability of getting a difference of 2 when 2 dices are rolled is 8 upon 36. Because for a dice, when 2 dices are rolled, what is the total? 36. Okay, n is 36. N is equal to 36 when 2 dices are rolled. Okay. Two dices are tossed. You can say the word roll, tossed. Okay. What is the probability of getting a total of 7 or more? Okay. Now, as you can appreciate that 7, 8, 9, 10, 11, 12. Okay. So you can either do it that way or you can do it 1 minus. Okay. So there are two ways of approaching this. So let us see them. Total of 7 or more means the same as 1 minus total of probability of total of 6 or less. Okay. Probability of total of 7 or more is 1 minus p total of 6. Okay. So what I'm going to do is I'm going to show you this method, and then I can also show you if you don't remember this method or you find it confusing, then you can use the other one. Now I will say 1 minus p of total of 6 or less. So let me see what are the total 6 or less. So what will happen here is, first let me consider total is 2, 1, 1. That is the lowest total possible. 2, then 3, 1, 2, 2, 1. Then 4, 1, 3, 3, 1. Okay. 4 and 2, 2. Then 5, 1, 4, 4, 1, 2, 2, 3, 3, 2. Then I have 5. Na? So 4, 1, 1, 4 is done. Then 5. I can't have a 5. So this is 2, 2. This is 3. This is 4. Then this is 5. Now 6. Now we have 6. Then 6 is 1, 5, 5, 1. Okay. 2, 4, 4, 2, 6. So 3, 3 is 6. Then 4, 4, 2 we have already taken. Then 5, 1 we have already taken. And then, so this is, and then we have, okay. So this is the case. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15 are there. So you have P of total 7 or more is equal to 1 minus P of 6 or less. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Minus 15 upon 36. Okay. So what this is 36 minus 15 upon 36. So how much is this? 21 upon 36. So if I divide by 7, it is equal to, divide by 3, it is equal to 7 upon 12. Okay. The other way, so this is the easier way where, because I'm trying to find out the smaller numbers when I'm talking about 7 or more, so you have a lot of options. So in that case you can still do it. If you can't, or if you're not able to do this, no problem, you can still do this. Total of 1 is 1 1, total of 2 is 1 3, 1 2, and then 1 2, 2 1. Total of 3 is equal to 1 2 and 2 1. Then 4 will be equal to 1 3, 3 1, 2 2. So that is 4. 5 will be equal to 1 4, 4 1, 2 3, 3 2. Okay. So this is 5. Then again you have 6 and so on. You have to do that all. And you will get again all these you will get as 21 upon 36. Okay. So that is also a method of doing, but it's more cumbersome than this method. Now I've also put in the formulas for your revision. A union B is equal to P of A plus P of B minus, okay, so this, remember the minus, P of A intersection B. What is the formula for conditional probability? P of B given A is equal to P of A intersection B upon PA. P of A intersection B is also given by P of B upon A, B given A into star PA. Okay. So you have this formula, if you remember them, that we have done. P of A given B is equal to P of A intersection B upon P of B. Okay. So if you remember at least one formula, the other one you can make it on your own also. Also, this is important. P of A minus B plus P of B minus A. P of A plus P of B minus 2 of PA intersection B. Expected frequency, this formula can maybe as N into P of A union B. Okay. So these are the formula that you must know. First one is the simple, which we have already done in sets. Conditional probability also there in sets. We have tried to find out P of A given B or B given A. Then you have this formula A minus B plus P of B minus A is equal to PA plus PB minus 2 times. Okay, minus 2 times A intersection B. And we have talked about what are mutually exclusive. What is this? Let us find out what is the probability associated with them. Yes, Indrajit, very good. Good one. Then you have probability of mutually exclusive events is P of A intersection B is nil. Null set by that is 0. This is actually not P. A intersection B is a null set because they are mutually exclusive. If one occurs, other does not occur. So how will it will look like this. This will be my A and this will be my B. Okay. So there is no intersection. It is not like this. So it is not like this. So this you have a phi set. Then P of A union B is P of A plus P of B. Why is that? Because P of A union B, we know the formula is P of A plus P of B minus P of A intersection B. Now we know P of A intersection B is 0. Okay, so this does not hold. So this will become P of A plus P of B. So we just have P of A union B to be the addition of 2. Mutually exhaustive events, P of A union B is 1. Events are equally likely means P of A will be equal to P of B. Okay. So now let us move to the next sum. If S is equal to 1, 2, 3, 4, 5, say X is such that X is an even number of points in S. So what will this be? This will be 2, 4, 6, correct? Then what will be? X is such that X is an odd number. So this is my A. What will be my B? 1, 3, 5. Okay. So this is my B. C is a multiple of 3 of points in S. So what will it be? It will be 3 and 6, right? Multiple of 3 will be 3 and 6. Why this? Only we have to choose from here. Okay. We have to choose from here. Now find out A intersection B. A intersection B. What is A intersection B? Are there any common here? No. So this is a 5 set. Then A intersection C. Anything common between A and C? Yes. So the number 6 is common. So you have 6. Then I have A union B. A union B means all the numbers in A and all the numbers in B. So this is 1, 2, 3, 4, 5 and 6. Okay. So I have A union B. A union C. A union C will be 2, 3, 4, 6. Okay. A union C. A minus B. A minus B. What are the elements in A which are not present in B? So 2 is not present in B. 4 is not present in B. 6 is not present in. So A minus B, it is 2, 4, 6. A minus C, present in A but not in C, that is 2 and 4. Okay, then P of A union B. Now I have to find the probability. So all these were numbers. So now probability of A union B. A union B is how much? 1, 2, 3, 4, 5, 6. So that is 6. What are the total number? 1, 2, 3, 4, 5, 6. 6 upon 6. Probability is 1. Probability of A union B union C. So 1, 2, 3, 4, 5, 6. And in C, what do I have? 3, 6. So again, it is same thing. 6 upon 6, which is equal to 1. Okay. Let us go to the problems now. 2 balls are drawn. Now 2 balls are drawn from a bag containing 5 white and 7 black balls. Okay, so there is a bag. There are how many? 5 white and 7 black. So bag contains 12 balls. Okay. So out of 12, 5 are white, 7 are black. So probability that it is a white ball is 5 by 12. Probability that it is a black ball is equal to 7 by 12. What is the probability that they would be of a different color? Okay. Now what can happen is that first is white and then second is black, and or it can be first is black and second is white. Okay. So what happens when first is black and second is white? So how much do I have? 5. 5 by 12. So probability of balls are of different color are this is the combination and this is the combination. White ball first. If the first is white, so this is 5 by 12 for it. Now 1 is less over here. So what will I have? 7 upon 11. So the next ball, there will be only 11 balls there. So how much is this? This is 35 upon 122. Oh, wait. And the second scenario is I got a black ball first. So black, there are 7 balls, 7 upon 12 into. There are 5 white balls and upon 11. Why the 11? Why not 12? Because once I've taken out one ball, I'm not replacing it in the bag. So eventually what happens is once I take out one ball, what are the number of balls remaining in the bag? It is 11. Okay. So this is equal to 35 upon 120, 132 plus 35 upon 132, which is equal to 70 upon 132. And you can simplify this further. Okay. So what is this? 4 ones, no, 4 I can't do this. 6 also I can't do. 2s are 35 if I divide. I can divide by 2. So 70 will be 35. When I divide 132, it will be 66. So 35 upon 66. So A will be the correct answer. कोई बात नहीं चंचल. You just follow the first method. That is more than enough. Second, what is the chance of throwing at least 7 in a single cast with 2 dice? Okay, so there are 2 dice. So, probability of, see, same question, Chanchal. At least 7 is equal to 1 minus P of a 6 or below. Not at least 6 or below. When I say at least 7, it is 1 minus 6 or below. Okay. So what they're saying is when I'm tossing 2 coins, 2 dice, and if I add the numbers on the top, so what will it be? So P of 6. So when I have a dice, so what I have done is for 6 or below, what will be the scenario? It is 1 1 1 3 1 3 1, then 1 2 2 1, 1 4 4 1, 1 5 5 1. Then this is 1. Now I begin with 2. So it will be 2 1. 2 1 we have already done. 2 2 and so on. So we have already done this. So it is, I think, 15. No? Writing them down all together once again. So you have a total of 6 or less is 15. Okay. So you just have to write them very simply. You have to just write them. So this is equal to 1 minus 15 upon how many is this? 36. So 36 minus 15 is 21 upon 36, which is also equal to 7 upon 12. So B will be the correct answer. Next sum is what is the chance of getting at least one defective item if 3 were drawn randomly in a lot containing 6 items, of which 2 are defective. So I have lamps. How many lamps I have? 6. Defective is 2. Non-defective will be how much? 6 minus 2, 4. What is the probability of getting a defective? It is 2 upon 6, which is equal to 1 by 3. What is the probability of getting not defective? Is equal to 4 by 6, which is equal to 2 by 3. 2 by 3 plus 1 by 3 is 3 upon 3, which is equal to 1. So that's all. That's also I should know of. What is the chance of getting this? Now if I'm drawing three items, okay, I'm drawing three items. So what will I have? At least one defective, okay. So P of at least one defective is what? Which is 1 minus P of no defect. So 1 minus. What is the probability of no defect? 2 by 3. That it is not defective. So 2 by 3. So how much is this? Oh no, you are having three items. Okay, not one. I thought it is one. Okay. So what will happen when there is no defect? So what will I do? I will draw how much? So from 4 into 6. Now 1 is gone. So it is 3 upon 5 into 2 upon 4. Okay. So how much will this be? 4 gets cancelled. 3 2s are gets cancelled. 2 2s are gets cancelled. So this is equal to 1 minus 1 by 5. So which is equal to 4 by 5. So probability at least one is defective. Now where did I get this 4 by 6? Because here when I choose the first one, okay, when I choose, see there are 6 lamps, 4 of them are perfectly alright. So when I choose the one lamp, what will happen, which is good? Out of 4, 3 will remain. And what about the total number of lamps? I had total 6 lamps. One is gone, so it will be 3 upon 5. So this is the explanation for this 3 upon 5. What is the explanation for 4 upon 6? Out of 6, 4 are non-damaged or non-defective. So I have 4 upon 6. Then once I remove one ball, what has happened? It has been removed from the non-defective. So that 4 non-defective will now become 3 non-defective. And out of the total 6 lamps, now I've already taken out. So remaining are 5. Next step will be again one more non-defective. So from 3 it will come to 2, and then from what was it? 6 it will come to 5, and then now it will come to 4. Okay. So this is the explanation. So 4 upon 5.8 will be the answer. Okay. If two unbiased dice are rolled together, what is the probability of getting no difference of point? Okay, so no difference of points. When will that occur? When you will have the numbers same on both the dice. So that will be 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. So what will this be? This will be 6 upon 36, because we are rolling two dice, so it is 36. 6 upon 36 is 1 by 6. So D will be the correct answer. Okay. Next is, if A, B, C are mutually exclusive, independent and exhaustive events, then what is the probability that they occur simultaneously? Okay, this is a very nice question. You can always mark it also. I love such type of question, because they're testing the concept, not the calculation. Okay, so they are mutually exclusive, independent. When I say mutually exclusive, means what? When one occurs, the other does not occur. So when it does not occur means, what is the probability that all of them are occurring? There will never be a scenario when both are occurring. Okay. Like for example, when I'm tossing a coin, what is the probability of getting both heads and tails with one coin? 0. Okay. So the answer is 0. Okay. There are 10 balls numbered 1 to 10 in the box. If one of them is selected at random, what is the probability that the number printed on the ball would be an odd number greater than 4? So, odd number greater than 4. So, this will be equal to 5, 7, 9. There are only 3. And what are the total? So, total balls are 10. So, probability of odd number greater than 4 is equal to 3 upon 10. Where did the 3 come from? 1, 2 and 3. So, 3 upon 10. So, it is 0.30. So, the D is the correct answer. Following are the wages of 8 workers in rupees. Okay. If one of the workers is selected at random, what is the probability that his wages would be lower than the average wage? Okay, so here what are they saying? Average wage. So first I must find the average of wage. So this is 50 plus 62 plus 40 plus 70 plus 45 plus 52, 56 sorry, plus 32 and plus 45. How many are there? 8 divided by 8. How much is this equal to? This is equal to 50. Okay. Now how many workers are there whose wages is less than 50? This 40, 45 and 32 and 45. 1, 2, 3, 4. So, what are the total number of workers? 8. So, this is equal to 0.50. Okay. So, yes, B will be the correct answer. ABC are mutually exclusive exhaustive events such that P of A is equal to 2 of PB is equal to 3 of PC. What is the P of B? Now, the fundamental property is what? Probabilities total should be equal to 1. Okay, that is the fundamental property. So, I write down P of A plus P of B plus P of C is equal to 1. Okay, all three additions should come to equal to 1. Now, instead of P of A, what do I want to find? I want to find P of B. So, I will write every number in terms of P of B. P of A is equal to 2 times P of B. So, instead of PA, I will write 2 times P of B. P of B, I will write it as it is. P of C, what is happening? 2 of PB is equal to 3 of PC. 2 of PB. So, how much is PC? PC will be equal to 2 upon 3 times P of B. 2 upon 3 times P of B. So, this will be plus 2 by 3 times P of B is equal to 1. Okay. Now, can I solve this? Yes. I take the denominator as 3. 3 2s are 6 P of B plus 3 P of B and plus 2 P of B. 6 plus 3, 9, 10, 11. 11 upon 3. Okay, so 11 upon 3 PB is equal to 1. So probability of getting a B cross when a fraction goes from the left to the right, when it's equal to sign, it flips. So it is equal to 3 upon 11. Okay, so this will be the correct answer. 3 upon 11. So B will be the correct answer. Yes, very good. Chanchal, Venkat Lakshmi, Om, Dhruv, Saloni. Yeah, very nice, very nice. Chanchal, that is a different question. That is, you don't have that type of, you have it in CBSE, ICSE, I think on now even the state boards have with replacement sums also. We are talking about the non-replacement sums, okay? Sulakshana is saying, bus okay. Okay. P of B is 0.3, P of A but not B is 0.4, and P of not A is 0.6. The events are what? Okay. Let me just take this. P of B is equal to 0.3. P of A not B is 0.4, and P of not A, that is not A is A dash. Okay. Not A is A dash is equal to 0.6. So what will happen here is, what are we asked to find out? Is this. Now, I know that P of A plus P of A dash is equal to 1. Okay. So how do I find P of A? A dash I already know. So what do I have? So if this is the case, if this is the case, and this is my A, this is my B. B I already know is 0.3. But there is this X which is the overlapping point. What will this be? 0.3 minus X. And what about A? I don't know anything about A, but I know that A dash is all this region. Okay. So it is all this region. So P of A and P of A dash is this. Now how much is this? I have P of A not B. P of A not B means what? Okay. This P of A not B is 0.4. So how much is P of A? This is 0.4. So P of A will be 0.4 plus X. Okay. And P of A dash is 0.6. P of A dash I know is 0.6. This should be equal to 1. 0.6 plus 0.4 plus 0.6 is 1. 1 plus X is equal to 1. And X will be equal to 1 minus 1, which is equal to 0. Therefore, means what? A intersection B is equal to 0. And so, sets are mutually exclusive. Okay, so they are mutually exclusive. Okay, why? Because A intersection B I got as 0, and that is why it is, the answer you get is mutually exclusive. Okay, this is the last sum we'll do for today. A bag contains 12 balls which are numbered 1 to 12. If a ball is selected at random, what is the probability that the number of the ball will be a multiple of 5 or 6? So, what is the scenario where you have number on ball is multiple of 5 or 6? This is equal to, you have 5, you have 6. What will be the next multiple of 5? 10. Multiple of 6, 12. Then 15. But my number, balls, always remember, don't get carried away. The total number is 12, maximum 12. So how many do I have? 1, 2, 3, 4. Now what is the probability? The probability of number 5 or 6 will be equal to how many are there? 1, 2, 3, 4. What are the total number of balls? 12 balls. So this is equal to 1 by 3. Okay, so D will be the correct answer. Okay, yeah. Do you want me to continue or shall we stop here? Yes, Om, correct. Yes. Okay, so we'll do these remaining sums. How many are there? Let me just check. Okay, there are a few, I think 10 sums maximum will be there. So those sums and the new sums that I want to take up, the word problems that are there in probability, let us take up the next time. The next time we don't have to revise anything. You just make sure that you know all the coins. When two coins are tossed, what will happen? You know when two dices are rolled, what happens. So you know the cards, you know the coins, you know the dices. Okay, all of this you should know of. Okay. Yes. So these are the sums I want you to, like these later sums are ones which I want you to do very clearly. You should be एकदम fresh mind के साथ आप लोग कीजिएगा. Okay. Yeah. Okay. Yeah. Thank you for your patient hearing. Have a great day ahead. Okay. Thank you. Yes, Bhavani, I would have loved to continue, but because of I want you to do. Chanchal, thank you. Ruhani saying amazing session. Chanchal is saying nice teacher. Asha is saying stop, ma'am. Okay, thanks. Yeah. Session end करें.